there already, right?
Yes.
They're at Berkeley. Okay. So guys, we're doing it. If you want to go to Berkeley, you're at the right place. Okay. Or Stanford, wherever you want to go, you should be ready. Brianna, I'm glad you brought that to my attention. Now, here's what I got to do, guys. I don't want to mislead you, because this exam on Wednesday can be demanding. I mean, it can be demanding. But you guys were with me at 4 o'clock. You may have to help me out to go through the same problem we went through, which is good though, for the class. Guys, they saw this. I brought it in. Part 1, let's say you open up the test on Wednesday, and it says to do this. Sketch this rational function, r of x, r for rational, and it looks like this. Watch carefully, just in case you see something similar to this. Oh, by the way, your extra credits. Mr. Park, could you go through real quick? I almost forgot. Could you go through real quickly and collect that extra credit?
It was due Wednesday.
Oh, Wednesday.
Yeah.
Boy. Okay. It is Wednesday. Jeez. Okay. R of x is equal to, here we go, guys. It was this. X squared plus 4x minus 12. And it's being divided by x subtract 6. I say you open up the exam on Wednesday, you see that. And the question is to graph it. It's a rational function. Now, to help you out, I will have those steps typed up on the exam, steps to follow, so you will not leave anything out. So step 1, they usually ask you to find the domain. And guys, here, I would suggest also go ahead and simplify this if you could. And I do see the top part, the numerator, will factor in x plus 6, x subtract 2, and of course you've got x subtract 6 here. Now you guys in that 4 o'clock session, watch, help me out. There it is, factored, simplified. Now domain, x cannot be 6. That would make a 0 denominator. That's all you have to say, you get credit for the domain. I think if I recall the steps, it says now simplify the expression, which we've already done. It might be this. Repeat what we have there. And all this is partial credit. Number 3, I think if I'm not wrong here, I asked you to find the x-intercepts and the y-intercept. And guys, to find the x-intercept, you merely set the function equal to 0. And when you set this function equal to 0, there's another way to think of it. It really comes down to setting the numerator equal to 0. So if you want to go just real quick and say, Professor, I'm just going to do it like this. Set that numerator equal to 0. Factor it, which we did earlier. X plus 6, x subtract 2. Split this up, you're going to end up with a negative 6 and a positive 2. Come out the way here so you can see it. Negative 6, 0, write this as an ordered pair, which looks much better. 2, 0. So those are my x-intercepts. Y-intercept, easier. You go back and replace all the x's by 0. In other words, you're trying to find this. R at 0. So if you go back and replace all these x's by 0, you're going to end up with a negative 12 over a negative 6, which is 2. And I'm going to write like this, which looks better as a y-intercept. So far, so good. Now, we got all that done. Number 4, I think they were asking if there is one, a horizontal asymptote, find it. Now, can anyone tell me anything about the asymptote? I know it's been a spring break, you've been off for a week. Is there a horizontal asymptote to worry about on this particular rational function? And what might give you a hint when you see the exam on Wednesday that there might be one. I'll go ahead and tell you in this case there's not one. Anyone recall what might happen on this one? And it varies. There is no horizontal on this one. Can anyone tell me how would I identify right quickly, Professor, there is none. So move on to the next type of asymptote, which is oblique. Anyone give me a reason why we skip the horizontal? In other words, there's no horizontal here to worry about, so you can go directly into find the oblique. Anyone give me a rationale why? The degree, okay, go back. So the degree here is 2. Is the degree also 2 down here? Highest x1. So that's the easiest case for a horizontal. So it's not horizontal there. But when I look at this, I think this is what she's telling me to do. If you look at the degrees, guys, the degree here is 2, the highest x1. The degree here is 1. Is the 1 in the numerator, the degree in the numerator, is it exactly 1 larger than the 1 in the denominator? If it is, that quickly tells you what type of an asymptote do you have on this graph. It's known as an oblique. So if the top degree is 1 larger, which it is in this case, you have an oblique. Now before I try to find it for you though, if this had been a 2, they do agree. Now we're going to have a horizontal. Does anyone have an idea where that horizontal will be located here if that should have happened? 1. The fastest is to look at the coefficients out front. You got 1 over 1, and you get 1 real quickly. If though the other case is, if this were, you guys have to remind me from the 4 o'clock session, if this were a, oh boy, here we go, 3, and this were a 1. What type of an asymptote do you think of now? They're not the same, I'll change them a little bit. Is 1 on top exactly 1 larger than 1 on the bottom? No, so it's not the type of oblique we want. So what type of an asymptote, horizontal, oblique, are the only 2 types? Vertical, which we'll get into later. What do you think, guys? Or could there be none? Just a little thought there.
Is it a parabola?
Okay, look at that, Brianna. I'm not gonna get into much detail here. Guys, define the oblique or the horizontal. Let me go back to horizontal. I said right quickly, there is none. The process is to make sure. Let me go back. Brianna, you are correct here, but let me change this. I think originally we had a 2 here and a 1 here. That's true, guys, in the original. What's my highest? Is that 2x squared? I think what the book suggested was to go through and divide everything by x squared, the highest. So we'll go through my function, divide everything by an x squared. That's the highest. Try to simplify it the best I can. On my denominator, everything by x squared division, and of course you end up with this. Just a little reminder, divide everything by the highest, x squared in this case. Simplify it, let's see if this color will work out for me. I'm going to end up with, this is 1. The x goes into x squared, and my second term is x. That's 4 over x. Best expressed as for a reason, 4 times 1 over x. The last term is 12 over x squared. For the purposes of what we want, best expressed as, I hope you guys can see this color, 12 times 1 over x, 1 over x. That's true? Just try and break it up into 1 over x as much as I can. On the bottom part, denominator. If I simplify the best I can, guys, this is 1 over x in algebra. The 6 over x squared, best expressed for what we want as 6 times 1 over x, 1 over x. Now, does anyone recall what am I allowed to do with the 1 over x? Why change everything into as many 1 over x's as I can? What can I do with the 1 over x? Anyone recall?
The
all zeros. And the reason why is the limit, as you make x get large, like this, of 1 over x. Got a little common sense here. You start out with 1 over 10. We'll make the x in the denominator get large. 1 over 10, 1 over 100, 1 over 1,000, 1 over 10,000. The value is getting closer and closer and closer to 0. So each one of these can be replaced by 0 from that statement. But the strange thing here, when I do that, of course this cancels out. 4 times 0 is 0. This is gone. 12 times 0 times 0, gone. I'm left with 1 in the numerator. Denominator, this is 0. 6 times 0 times 0, 0. Altogether, 0. Now, what are you going to say in math for 1 over 0? Is that undefined? So it says, in an attempt to do this, this one has no horizontal asymptote. Not going to work out. Okay? Therefore, we're going to run into an oblique. I'm wondering, since this test is a little lengthy, would it be beneficial if you knew ahead of time, if I said find, and I left out the horizontal one, you did not see the horizontal type on the exam, meaning there is none, rather than you trying to come up with if there is one or is there not one. Suppose you saw oblique, which means there is an oblique. Would that help? If I leave out the one that is not going to work. Would that help if I did that? Oh boy, spring break. Yeah. Okay guys, this one has no oblique. Now, the oblique, gotta do long division. And that means go back to the original, you're dividing x subtract 6, they call that the divisor, into the dividend, just like that. And we start the long division. First thing you ask yourself is, how many times will x go into x squared? You get a start. So on the side here, you're doing this. What is x squared divided by x from algebra? It's just x. One of the x's will cancel. So that's going to give you a start of x up here. Then you take x times your divisor, the outside. So x times x minus 6 will give you x squared, subtract 6x. Long division. Next step, you're supposed to now subtract those two, which means change signs. X squared will drop out, which they should. I'm going to end up with 10x. Bring down my next term, subtract 12. Let's go ahead and do it here. And you start the process again, all over. X into 10x. So on the side, you're asking yourself this, which is 10. The x's cancel. You end up with a 10 up here. X into this. Do your multiplication. 10 times the outside, the divisor. You end up with 10x. Subtract, looks like 60. Is that 60, guys? Help me out. I think it is. Then subtract for the last time, change your signs. And when I change my signs, you're going to give a negative and a positive. 10x is canceled, which they should. A remainder here of 48. Is that true? If I line things up? Now I'm looking for mx plus b. It should be a linear oblique. Now, is this on top right now in the form of mx plus b? Is that true, guys? So this down here, this remainder is going to play no part. Don't mess with it. You're just concerned about that on top there, x plus 10. So this thing's going to have a slope of 1 and a y-intercept b of 10. That's going to be a straight line acting as an oblique. Now, I think I have all the details. There is no hole on the graph. By the way, guys, when would I have a hole in the graph? This one has no hole on the graph. When would I have a hole in the graph? Who recalls?
If the terms at the top cancel out.
If something cancels. Absolutely. So if this has been x plus six, and all of a sudden down here, another x plus six. The x plus six is for the cancel, and you solve that x plus six, set equal to 0, you get -6, and from there, you find the location of the hole in the graph. Guys, I think on this one, you guys, who were with me at 4 o'clock, I think that's it, wasn't it? I think we're ready to graph it with this. There's no hole in the graph. This is my, oblique asymptote.
Vertical asymptote.
Oh, we got vertical, hang on then. Number 6. Let's pick that up. Vertical asymptote, one of the easiest to find. Process is to set the denominator, oh my goodness, here's my denominator. Set that denominator equal to 0 and solve. And we'll end up with 6. Now do we have all the information? Let me slow down, make sure you see all the information here, guys. This was a little strange to open up with after spring break, but we gotta do what we gotta do. Any concerns about the information though, before I get into it? This is what it's in practice. This is what it's in practice. That long division. Michael, if I recall before spring break, you said sometimes what you could do, Professor, rather than long division, you can at certain times do this by synthetic division. Remind the class what you would do. He said maybe in certain cases, you could, Professor, I realize this process works. But he says you could maybe do it by synthetic rather than the regular long division.
When the denominator is a single degree.
Okay.
You can invert the,
Now, if you're gonna do it by synthetic, I'll need something here.
invert the last number, so -6 becomes a 6.
Okay, thank you. Set that equal to 0, you get 6, he says. And then you jot down my coefficients, just like on synthetic division. 1 for my coefficients and my constant. That's what, guys? In certain cases, you do this. Let's start the synthetic. Always 0 here. 1, product is 6, 10, 60. I guess that's 48. Please tell me, do those numbers from synthetic name 1x plus 10, remainder 48? So that synthetic could come in handy. Okay, doesn't always work, but looks like it would work on this one. Okay, now I'm seeing some looks. I don't know whether it's from spring break. We've been away from each other for a week. Whew. And I hit you with the hard one to open up class. Now can we put all this together, see what this graph looks like? Now you gotta keep in mind this, because of all the parts here. The points, this could be easily 12 to 15 points. But, I'm giving you points for every one of these parts. So you may get all this correct and still do pretty well on that particular problem and miss the graph. You may have all that over there correct, you just for some reason messed up on the graph and still get a good score on this particular problem. Now I'm gonna see what it looks like though. Guys, on the grid, let's see what it looks like if I place things on here. Okay, going back, I have, the intercept. Looks like it is -6 and a +2. Go out for -6. It's right here. And a +2. Now, do not let me mess up jumping back and forth on this. Y-intercept up to. Here. I'm gonna put the vertical next. Now here's no horizontal, let me pick up that vertical. There's a vertical asymptote out at 6. Out here, in this, guys, I'm going to do it right here. A vertical line that you cannot let the graph touch. Oblique. oblique is unusual. It's this, it's x plus 10. X plus b, slope 1, y-intercept 10, or you could find the x and y intercepts for this. Plot that, connect, and get your oblique straight line. Guys, we'll do the intercepts rather than x plus b. If you set this equal to 0, you're going to end up with an x-intercept at negative 10, I think. So spin this out. Now you guys, in my 4 o'clock session, is all this correct so far? Out here, do this in green. The point on that oblique asymptote. That's the x-intercept. Y-intercept, replace x by 0 in the red here, and you end up with 10. Let's go to 10. Up here, mark this in green, and I'll get out of your way here. Those 2 points connected should give me the oblique, some textbooks call this a slant asymptote, so it's going to look something like this. I moved up. Let's see if you guys will agree. There's my opening. We got the vertical down here. We have the intercepts. Am I leaving anything out? Do we have all the information on there? Now, how many pieces to this graph should there be? It all depends on the vertical asymptotes. How many vertical asymptotes do I have here? 1. So there should be something happening to the left of that 6. There's a piece over here somewhere. And there's a piece to the right of 6. Now to the left, you've got to connect this. You've got to connect those intercepts. You've got to make sure it follows the green and the blue asymptotes. So a shape like what would do that? And you guys in my 4 o'clock session, make sure, guys, does it look something like this? I think Michael, you showed us in the 4 o'clock session, something like this. Guys, this follows the green, which it should. There's my oblique. It comes on the up and picks up 2. Curves, comes back down, picks up 2, and swoops down to follow the vertical. That's a piece of the graph. Does that make sense? Yes. Now, the question is, there should be a piece of the graph also to the right. Guys, to the right of the vertical asymptote. Now, I mean my vertical asymptote's out here. There's the vertical. There should be something out there. It's vacant out here right now, but there should be something out there. The best I can do is, I can extend my green like that. And now I have my vertical and my green extended, which may help me tell where the last piece of the graph is. Does anyone have an idea where the last piece of this graph might be to follow those asymptotes? There are no intercepts out there, but you've got to follow the asymptotes. Any thought on where or what does my sketch look like out to the right? It's got to follow, not touch the vertical. It's got to follow the green. Go for it.
Is it like the top right corner?
In the right corner up here, doing something like this. That follows the vertical, follows the oblique. That's the graph. Now, I'm looking at this. Look how much time it took me, half an hour at least. And we're not quite finished with it, to do this one problem. That's why I think the rational function problem on the exam on Wednesday probably will be the most demanding one of the problems on the test. Any concerns here? we do something like this. Now keep in mind, this one has no hole on the graph. There could be a hole on the graph on yours. Okay, so this one did not have a hole on the graph. Brianna?
Wait, does it ever cross the oblique?
Ah, beautiful, beautiful. I've seen some that will. Brianna, I'm glad you brought this up. Anyone tell me, guys, how one do it? Can anyone tell me how does one find a crossover point? If there is one, I like one, she says, Professor, is it possible? I see this thing's going out forever, it's gonna follow that green. Will that pink, I guess pink graph there, yeah, pink graph, will that finally intersect way out there somewhere, the green? Might they intersect? Anyone tell me algebraically, how could I say yes, and we'll find it, or no, they will not intersect? This pink and the green will not intersect. Brianna, good question. Guys, any questions, concerns or questions or details or something to find out this, if there is a crossover point? So what you do, go for it.
When you set the original function equals the horizontal axis.
Thank you. You set the original function, which is this. Thank you so much. This is the original function. I'm saying, Professor, when set that equal to the oblique. Well, the oblique is strange itself. It's that. It's x plus 10. Is that true? You set them equal. Just like we would do for a horizontal. Now, I want to solve this. I think the fastest way, Brianna, to solve this is to cross multiply. It's up to you. I will just quickly do a cross multiplication. Cross multiplication in this direction would merely give me x squared plus 4x subtract 12. The cross multiplication in this case, I need to multiply those two together. And guys, when you do, some of you guys call it FOIL or expand it out, I think you're going to end up with x squared, help me out here guys, minus 6x plus 4x minus 60, I think. We multiply these two together. Is that true? Quick multiplication, cross multiplication. Now if you attempt to solve it, oh, unless you brought this up, say, Professor, I gotta solve that equation for x. Well, the x squared will drop out. It just so happens what else drops out? The 4x's. You have no x to solve for. Therefore, there will not be an intersection point. You can't solve this thing, all the x's given. Brianna, I'm glad you brought that up. Okay, guys, take a close look. That's the only one I'm gonna work out for you before the exam comes up. Unless you join me at 4 o'clock on Wednesday and bring something in. Okay, now, a few questions after you get the graph done. Now let's go into the calculus. Let's find the limit, if we accept this graph, as x is approaching infinity. Here we go, Brianna. Of this function, it's called r of x. Since I see the graph, it says the x-axis is down here. So when it says x is approaching infinity, you're walking out this way forever. That's x is approaching infinity along the x-axis. But you're dragging that graph along with you. Now what is that little pink graph up there, little piece of it? What's it doing as you walk this way and you drag that graph along with you? What would be the best description of what is that little pink graph doing up there? Is it rising? Is it also getting closer and closer to the oblique? Okay, so it's rising, so I'll accept this. It's going through infinity. Another question I'm going to ask you is find the limit as x is approaching, guys, let me see what's going to happen here. Why not? Negative infinity of this function. Now since I have the graph in front of me that says now go to the x-axis, but this time you're on the x, you're going this direction, but you're going to pull the graph along with you. So if you're moving in that direction to the left and you're going this way forever, that's what this right here means. And you're going to pull that graph along with you. What's the graph, the pink graph doing? As you walk this way, you drag it along with you. Is it constantly dropping down? As I move further and further to the left. Described as negative infinity. Next one, find the limit. Let's try this one. X is approaching 6 from the left of this function. Superscript of a negative sign. Guys, 6 is the location of my vertical asymptote. You're approaching 6, before stay on the left. That says you're coming in this direction. You're getting awfully close to 6, but you're on the left. Now find the pink graph. What's my pink graph doing the closer I get to 6? The pink graph is doing what? Is it dropping down through negative infinity the closer I get to 6? Mr. Park, do me a favor. Mr. Berkeley. To the left of 6, we're supposed to get close. We're approaching 6 on the left. Let's try 5.999, 1, 2, 3 nines. That's awfully close to 6, and you're on the left. Would you please go back? I would not ask my students to do this though. You do it either here, Park, or here. Replace those x's by 5.999 and see what this original function gives you for an answer. Just trying to figure it out.
Negative 48K, 48,000.
48,000.
Yeah.
It's already up to negative 48,000. So now does that confirm that maybe this is reasonable? It's going through negative infinity. So he says at I think I asked him to try 5.999. And if you get even closer, 5.9999, it'll even get worse. It'll be a negative, another big number. So negative infinity makes sense. Okay, guys, ask before I erase. Any concerns here? Take it off. Okay, feel good about this? Now, here's where I am as an instructor. I took some of my spring break looking through where we are, where we're going, and what's going to take us there. This one was a workout, guys. I mean, it was a workout. There's the graph. Wow. Okay. Now, I have my notes here to sort of ease into where we were before spring break came up and ease back into what we were doing. Please tell me, did we discuss composite functions? How to form a composite? I think I had a handout, we sort of looked at it. So we got into that and called it part 2. And then into it. We're doing this. I will tell you ahead of time, this is not as demanding as those rational functions. Now, I'm looking at, I'm gonna use my notation, if they ask me to find f circle g with respect to x. They use a little circle to indicate they want a composite. Or it could be written in this order, g circle f of x. Or it could be f with itself, f circle f of x. And of course, this one, g forgotten what it was? Let's go back to the first one. F circle G means you gotta find F of G of X. The next one, G circle F, you gotta find G of F of X, which can get tricky. F with F, F of F of X. These are my definitions. And here's G of G of X. And those are my definitions. Now, if I were to use those definitions for an example, to make this work out, we will be doing way off. Guys, I brought an example that looks nice. Try to find it here. Yeah, here it is. I'm gonna give you two functions. I'm gonna give you f of x is equal to square root x. We've worked with that function before. That's why I brought it in. And my second function, try to use a different color here, g of x is equal to, and it looks like it's square root 2 subtract x. Another way I should find a few things here. Okay, fine. Goes. First, I'd like to find, if I could, and I'd like to use up these different colors, but here goes. Just write in one color here, save a little time here. I'd like to find f circle g of x, based on the given, which means f of g of x. Now, when I jump into it, again, guys, this is going to be much, much, much easier than rational functions. What does this translate into? You take the g of x, the inside, you've got to find the g of x function, go back to the given, and put it inside the f. So if I do that right here, that would be taking the blue into the green. If I do that, I'm going to end up with this, square root, and do not let me miss this, guys, square root of 2 subtract x. Does it look like that if I place the g into the f? Now, if you want to leave it like that, I'm happy. I think it looks better like this, myself. That's fourth root of 2 subtract x. Now, everyone think they see why it's a fourth root? Got square root with the square root. And by the way, can anyone tell me, I was talking to a professor today that was shocked in his calc class. He asked his calc students today to express maybe square root 2 minus x with a fractional exponent. Don't use the square root symbol. Rewrite just that part for a reason with a fractional exponent. Anyone tell me what square root 2 minus x would look like? And they didn't know. With a fractional exponent.
1/4.
Well, I want just the inside first. Just the square root part inside. What would the square root of 2 minus x just it look like with a fractional exponent? Was it 2 minus x raised to what? 1/2. That means square root 2 minus x. But, Brianna, I think you were looking at this. Now, is there also a larger square root around that? She says now, another raised to 1/2. Take care of both of them. And here, if you multiply these two exponents from algebra together, you end up with 2 minus x raised to the 1/4, which is that. That now says 4th root of 2 minus x. So guys, that's my composite. It's done. Now, here's what I did not get a chance, I don't think, before spring break to do with you guys. They will also ask us, after you find the composite, the answer, don't stop there. Now find the domain of that composite, right like this. What am I allowed to replace x by in that answer? If I stand here and just observe some numbers, guys, am I allowed to replace x by 2 at random? Can I replace x by 2 and not run into a difficulty? If I replace x by 2, do I end up with 0? And is there a square root or fourth root of 0? There is a 0. So I'm gonna put a 2 in there. Can I put a 3 in there? No. Put a 3 in there for x, you end up with 2 subtract 3, that would give you a -1. And there is no fourth root of a -1. Could I put in a -2? If I wish. If I replace x by a -2 here with that subtraction sign there already, it's going to turn into a +2. 2 plus 2 gives me what, 4? And so it's possible to take a fourth root of 4, of course it is. So there's some numbers I can use, some numbers I can't. They want to know what can I use for the domain. Guys, a nice way to find this is, help me out, must this be something that we've discussed sort of before to make this sensible? I got a fourth root of 2 minus x. Can anyone tell me a restriction on that 2 minus x to make this happen? What must that, underneath that fourth root, you think must be to make this thing work?
I'm gonna be less than or equal to 2.
Oh, you already got the answer. Okay, you're saying first, the 2 minus x, professor, to make sense to begin with, must be that type of a number. Sort of like a square root. You can't take the fourth root of a negative. So that 2 subtract x underneath that fourth root must be greater than or equal to 0. Now if you solve it, I don't think he's already done it for me. For x, move the 2 over, divide both sides, multiply both sides by a negative, reverse your symbol. You're going to end up with x is less than or equal to 2. Now, okay, here goes. Now, let me go back. We'll accept that for right now. Let's go back and identify the domains of the individual functions that were given. Guys, the domain on my green function, we all know what it is. For that square root to make sense, the x must be that. For the blue one, for the g, the domain, 2 subtract x, must be this for a square root. Solve for x, no problem, reverse your symbol. There's the domain. Now we're saying the domain, when you put those two together as a composite, is this. And I notice it matches up with one of these, sometimes it does, sometimes it doesn't. Make sense, guys? Okay. Now my next one here, number 2. Very, very, very careful. Number 2, up here. Now let's try to find, I'll use this color again. Let's turn it around. Let's try to find G circle F of x. Which by definition says this, G of f of x.